In this next chapter, we're going to take some of our raw materials and turn them into our triboelectric layers for the Tang device. What you'll need for this segment is the adhesive-backed copper foil tape, adhesive-backed PTFE film, adhesive-backed polyurethane, double-sided foam tape, a good pair of calipers that go up to at least 100 millimeters, a nice straight edge, a nice sharp utility knife, and the 2 acrylic plates that we cut beforehand. To start off, we want to get these acrylic plates nice and clean. We're using some lint-free cloths and some isopropanol. This ensures that no lint is caught on the acrylic plate that's going to get trapped underneath all of these adhesive layers that we add. I pull out some of the copper foil tape and remove the paper backing, and very gently align the acrylic plate to the copper foil tape, apply a little bit of tension as it gets laid down. Then just cut to size with your nice sharp utility knife. Be sure you leave a little bit of excess around the 2 tabs that stick off the acrylic plate, and that'll give you a place to solder your wire leads to later. I fold back that little bit of excess, and that'll give us plenty of surface area for soldering later. Your hands to just smooth things out the best you can. It'll never be perfect, but the flatter you get it here, the better your functionality will be. Here I'm grabbing the PTFE film and just cutting off a little piece that's going to be slightly oversized, and we're going to cut that down later. To create 2 discrete electrodes out of this copper foil tape, we need to cut a channel between them that's going to be perfectly centered in the middle. So what I'm doing here is I'm taking my calipers, setting them to 100 millimeters, and I'm marking 100 millimeters from each edge. I then score another small mark right in the middle of those 2 marks I made with the calipers on each end, and that gives me a line that's almost perfectly centered. Now we want this channel to be 7.5 millimeters wide, so I measure 3.75 millimeters on either side of that center scored line. The straight edge is there to then trace that line across, and I gently scrape off the material that's in the middle of that gap. And now we have 2 separate copper electrodes mounted onto our acrylic substrate. Be very careful to remove all the material in this gap, because any leftover scraps of copper can provide an easy place for the electricity to arc between our electrodes. We're now ready to add the Teflon layer, so we're taking our oversized piece of Teflon, removing the paper backing, and again we're going to very delicately wipe things down and lay our copper foil so it sits against the Teflon. Once again, roll out all the bubbles. A heat gun can be useful if there are any especially large bubbles that are trapped, and we're then going to cut things down to size. Now your top Tang plate is fully assembled. Be sure you trim away the Teflon that covers over those copper tabs that we left for soldering wire leads later. Now I need to assemble the bottom plate for the Tang. That's more or less the same process. We're just taking our other acrylic cutout and we're laying our adhesive-backed polyurethane on top of that. Be sure your knife is nice and sharp, otherwise you'll get a jagged edge on this polyurethane. Now you've got a hand-powered Tang. To make your Tang automated, we're going to attach it to the electronics we spent so much time building. I start by putting 4 pieces of our double-sided tape onto the carriage of the linear motor actuator. We're then going to take our bottom Tang plate and very gently lay it down onto this double-sided tape, making sure to keep it nice and square with the carriage. We want this piece to be not quite centered on the carriage, but actually a little bit closer towards the electronics box. You'll see why that's best in just a minute. Now we're adding the top bracket to the frame that's going to hold our top Tang plate against the bottom Tang plate. With the top bracket installed, we're going to start aligning the top tang plate to the bottom tang plate. Again, this plate is held in place to the frame by double-sided foam tape, so we're going to cut off a few sections, apply them to the top bracket, and then while our two tang plates are aligned, we're going to lower the bracket onto the top tang plate. Around here is where I realized that those copper tabs that are going to hold our wire leads are sitting a little bit too close to the frame, and we really just don't want another contact point where electricity can arc, so I'm going to remove the bottom tang plate, shift it a little bit closer to the electronics box, and then reattach it. Now we have a little bit more clearance between the tabs and the frame. I'm now going to run the carriage to both sides of the upper tang plate, and I make sure that the two plates are still aligned. If they're not quite perfect, you're going to want to detach the top plate from the frame and realign it. With everything nice in place, we're going to want to lock down the top bracket. It is important to provide a consistent pressure of the two tang plates against one another, so I like to apply around 5 pounds of pressure while the carriage is at one end of the plate, tighten down those two brackets, move the carriage to the other side of the plate, again put down about 5 pounds of pressure, and then tighten down the other two brackets. If it's not quite perfect, then you can repeat this process a few times until you have a nice, even pressure across the full range of the sliding motion. If you put too much pressure between the plates, then the motor won't be able to overcome the friction and you'll hear it start to stall. If there's not enough pressure, you might not get enough voltage. Some areas the copper tabs might still be kind of close to the frame. I found that it can be a little bit useful to add electrical tape to those areas if you start to observe arcing. Now we're going to set up the location of the optical limit switch on the rail. We want to set it so that it activates before the carriage meets the end of the rail. Once in position, tighten down the bolts that hold it in place. During the homing sequence, the carriage moves a set distance away from the limit switch. So to keep the two tang plates aligned during operation, you can either dial in the position of the optical limit switch, or you can change the steps away from the limit switch in the Arduino sketch file. I've found it's usually easiest to just slightly nudge the position of the optical limit switch. Now that everything's in place, we want to test that it can function across all speeds. Set that speed dial to 100% and watch it go. Here I notice that the carriage starts to slip and loses its position against the two tang plates, and you can see that the coupler is starting to slide in place. This is because I didn't quite tighten down the coupler enough. Give it another few cranks and it should be good to go. With the freshly tightened coupler, we should be good to go. So again, I'm turning the system on, letting it run at 100% speed, and I'm gonna feel on both ends of the top tang plate to make sure that the carriage comes right up to the end but not past it. So here it looks like it's functioning well. So I'm gonna let it run for a little bit and make sure that it keeps position. Looks like it's all set, so I'm going to dial it back to our normal operating speed, and we're good to go with this tang device.